All right, everyone, welcome. This is kind of a long awaited day. I finally have
Yeah.
my friend Bradley with Savage Fabrication on. He and I have been working on projects of mine and chatting for a few years now. And I just figured at one point we wanted to try doing a podcast style video because there's a lot of good conversations we have where we're like, man, this would be really good to help other people. Um, that's kind of what we try to do is get the right information out to people. And
Yep.
Bradley does this for a living. I can let him introduce himself here in a second, but I'm pretty much just going to follow along some of the stuff that we discuss, and then just let him take over from his experience because he's kind of the master here, and I'm just following along trying to catch up and ride his coattails. So anyway, Bradley, you can introduce yourself a little bit if you want.
So I'm Savage. Go by Savage Fabrication, usually on most social media platforms. It's Bradley Carter. Uh, I'm the person that'll take most turbochargers, cut them apart, and weld them back together without any rules, reasons, or rhymes. So a lot of the reason kind of why I've became a big deal is because I've taken chargers designed for more modern um, engines and then cut them apart and retrofit them backwards to fit older applications. And that's kind of became kind of the staple of why I'm around. And then beyond that, I really study how turbochargers work, engines work, and just about anything kind of functions to really look into like how it functions, why it functions, and how does it help me or how does it help you create something that works for you instead of against you is kind of a big part of what I do. Because there's a lot of magical things out there, but a lot of the magic isn't for you exactly, but you might think it is, where like only 10% of 90% of whatever it is kind of what you're looking for, versus you should find what 90% of what you're doing is for you, where the 10% you can give up 10% and it's fine. Like you won't notice.
That's one thing I think I like to show people when they ask or guide them into the right direction is someone they might show some hero build that's making 1,000 horsepower and they're like, I've got to do this to my engine or my turbo, and I'm like, well, you're making 400 horsepower on a street car. This guy's like a full drag application. Like, that is something that worked at his power level or his build or whatever, but it's not necessarily necessary. It's like application specific is really a huge thing that's hard to overcome because sometimes people are like, I want the best. And I think that's what we wanted to
Yeah.
talk about tonight was like, some people are like, give me what's the best turbocharger? Well, it's relative to what the application is because you won't be happy if you have a drag turbo and you really want like you have like a street car that's you got to drive to work every day in and stuff like that. So that's one that we kind of wanted to go over a little bit.
I think that's like a good point because like Shane, like in one of Shane T's little um, posts he made on Instagram, like that triple turbo 1.8 liter, like that charger setup doesn't start spooling until 10,000, right? So we know that the converter stall is around 10,000 plus. It makes it makes 2,000 or 3,000 horsepower, but is that really the best for everybody?
Exactly. Yeah.
Like it's nice to have that Instagram, Snapchat, Facebook post, but you always have to remember that you're the one that has to drive it every day.
Absolutely.
Like
Like,
there's a rhyme for a reason. Like
yeah, absolutely. And I think that's where working with you over the past few years has been really cool is because we started at like the smallest of the whole set HE 341 to 351 combinations and then worked my way up to where now I have like 700 horse worth of compressor. Before it was like, you know, basically a bog standard HE 341. And it was cool to see like each of those iterations and how like the trade-offs, like you'll be like, well, you know, the as soon as I went to the the 67 mil turbine that you set up for me, it was like huge up top, and you see that little bit of a trade-off down low, but it was minimal compared to going to like a 67 or something right away. So that was really cool, and that's kind of what I've loved to see along the journey with the turbos that I've worked on from you, is like you've basically been able to like show where you can make compromises and not have like a really poor drivability experience for a street vehicle.
Yeah, it's always spool up. I always get kind of like the definition of spool up is the driver's feel of torque output. Um, so if you lower boost pressure, you have to make it up in volumetric efficiency, and you won't make it up for one. You're as far as like boost goes, like you always lose a little bit under the curve. But if you can make up enough in the VE curve down low and hold on the VE, it'll pick up torque enough that the owner's okay with it. And then once the charger comes online, like it's game over, right? Like it makes boost, it takes off, and
It's like
everything's grand.
yeah, that's another huge one too, is like perception. Like everybody's idea of like what streetable or what like
Yeah.
boost threshold. I think that one, there's lots of good videos on like boost threshold versus like turbo lag and stuff. But I think most people are probably concerned about boost threshold and like getting to their max boost target. That one's kind of hard too, because I talk to people a lot and they're like, well, what's the, they're like, where's boost threshold or something? And I'm like, well, it'll start making positive boost pressure at like whatever, 2,500. But then I'm not hitting wastegate, or I'm not hitting my boost target until, I don't know, 3,100 or whatever. I think that's probably where people are really, they get stuff mixed up too, is where they're like, oh yeah, like this is where you're gonna feel it, right? Like it'll come online, but like you're not gonna really feel peak torque or the full onset of the turbo until it it rises to that point. But that's a whole nother one where it's like it goes pretty deep. You and I have had conversations about that too, where it's like you pretty much have to have like quite a bit of data to accurately see that. Like I've tried to go out and get some good data of like a repeatable boost onset, and it's not actually as easy as you'd think. I don't know if you experience that too, but you have to have a pretty loaded, and it's got to be like repeating conditions and on a hill or a dyno or something. Sometimes it's not as easy as it would.
Well, like in the
seem.
diesels, like as far as the diesels go, we pretty much don't count anything like third gear below. So
Yeah.
like third gear on a manual trans will be just under direct drive, and then third gear on autos direct drive on most of them, and then some of them will be just under direct drive. Because one and two, even with a turbocharger change, but there's not enough load to get the charger to reach like a stabilized time. So it'll click off one, two, three before the turbo even hits like where it's going to stabilize at, as far as like compressor outlet temperature and target boost pressure. Most of the time, like for most of the time.
I know we're jumping around a lot, but that just reminded me of the day that I got I think it was the 9 blade set up on my car that you sent out. So we had the 60, it's a HE351 for people that haven't seen it. The HE351 60 compressor 67 9 blade. And I went out and I was doing a few runs because we were looking for back pressure. So I'd send data logs to Bradley. I was like, hey, here we go. And the first data log, we're like, this looks worse. And Bradley's like, what are you like? What gear are you going in? I'm like, oh, I didn't even think of it, but the engine is outrunning the turbocharger. So it like per RPM, the turbocharger hasn't even got up to speed yet by the time the engine has gone through the transient on that gear. It was pretty interesting. So I'm like, oh, okay, I'll go out, do like a fourth gear 1-to-1 hit, and then it showed everything. We were like, oh, that's where it's at. Like it really did drop the back pressure quite a bit, but you couldn't even see it in any gear other than like 1-to-1 on like a highway run. So
and then it gets even crazier is if you like can hold that gear for longer, or you raise the target pressure in that gear depending on what the charger geometry is. Like it can get better or it can get worse within the time frame on that gear.
Oh, absolutely. I just remember that one. That one stuck out to me as like a huge learning experience because I was like, wow, you have to be careful when you do testing too because it's super easy if you're not. I don't know how to explain this. Like if you're not aware of all the pitfalls, it
Yeah.
can you can just like I could have gone out and just posted that and been like, hey guys, this 9 centimeter or this 9 blade is garbage, and like who's to say that test was accurate? You know what I mean? Like I can see how people can get like if they don't look into every aspect of it or you're not carefully considering all of the variables in the system and even the test, like you can get caught up pretty fast in something that's not really accurate and it doesn't really display what that's doing because I think a lot of the things that get measured or looked at as a measurement on a turbocharger are like steady state things like
Yeah.
um, compressor maps. Like one thing we've wanted to bring up too is like you look at a compressor map and it's like that's really easy to look at in a steady state, but it really doesn't show the whole picture of how a car is going to drive, or any engine is going to run with
Yeah.
that, right?
Well, it's like always like it's a very dynamic system. So you're always traversing around it. And when you plot it, you're plotting a steady state point is always something to kind of consider versus like how it looks to traverse it. And then on top of that, it does not mean that the turbine map matches the compressor map. Like you want to get like super wizardry technical. That's like the next part of it.
That's a huge one, and that's one that we've been chatting about for a couple years now, probably is, and I'm still trying to wrap my head around some of it too because there's a lot going on and it's easy. I think the biggest thing for me is like it's easy to think that everything's at standard temperature and pressure. So like I'll I'll think about a turbine or I'll think about a system on this and you're trying to explain something to me. I'm like, well, why does it do that if it's you know if and then I look at some stuff that's standard temperature and pressure on Wikipedia or whatever, and you're like, well, you got to think of it. It's like we're talking like 1400 degrees Fahrenheit exhaust temperature. So you're like everything changes with temperature, and then that you're dealing with like say you're dealing with 60 pounds of dry pressure over atmosphere. It's like everything the atmosphere that a turbine lives in that you've been explaining to me over the years is like so wildly different from a compressor that it's like easy to just assume that like this thing breathes atmosphere, which
Yeah.
its planet where it lives is in a completely different world, and that's a big one that I've learned over the years working with you is like you can't assume anything. You have to like basically get it all plotted down and like what temperatures and pressures you're dealing with when you start thinking about these guys over a
Yeah.
compressor.
Yeah, they have like they have like almost an infinitely variable atmosphere compared to the compressor side.
Yeah, the compressor is a cakewalk. Like you've
Hmm.
said before, like a compressor is very predictable to make not assumptions, but like predictions about like what it's going to
Yeah.
do on an engine.
Yeah, you can figure out like I would say you can figure out within 90% of where you probably are at on a compressor map pretty like within like 2 minutes. It's not hard.
Yeah,
Uh,
uh, you've shown me some pretty good methods of doing that, and I'd like to show it at some point. I don't know where we'll get to on that, but it's actually quite straightforward. Like
Yeah.
there's a bunch of different people that explain it and stuff. I've seen a ton of different videos on YouTube, and there's a bunch of articles too. Like Garrett has some like TurboTech articles on it, but there's actually like an easier way to look at it, and I think Bradley has shown me that over the years is being able to map pressure ratios is like one of the key parts of that, and that's another thing trying to get my head wrapped around when I was originally jumping into all this is not thinking about boost pressure as much as pressure ratio when it comes to turbine or compressors and turbines as well. But pressure ratios are really what compressors live off of, which is
Yeah.
something that people don't talk about much.
Well, it's like on your car when I kind of first hit you up about it. Like I know what made it easy from my perspective was I looked up your engines, like I just Googled what is your engine's peak horsepower, peak torque, and I'm like, okay, it's here. Then I looked at your dynograph of that dyno video, and I was like, okay, so with the turbocharger installed, peak torque and peak horsepower is lower than it was in A. I'm like, this kind of easy win, right? So it's not outflowing the compressor because the wheel horsepower was it 430, and you have about 550 on the table with that compressor you're on. Um, so like turbine's choked up. I was like, the only way you can move peak torque or peak horsepower, and it's an equation, right? So they both move with one another. You can mention either one moving left, move down is turbines in a choke flow state. So drive pressure is so high to produce 430 that it's causing the NA engine to go volumetrically inefficient earlier than it should. And the bare minimum is the VE should remain the same as it is NA. So I was like, we'll just throw a big turbine in this thing if I could talk them into it, and it'll instantly pick up. It should pick up, 80 to 100, and we're about on target. It picked up like 150, I think.
Yeah, we went from 385, or wait, yeah, 385 on the stock turbo, and then as soon as you put the wheel in, it the highest run was 560. I think
Hmm.
it was 560. Like, and that was like, I mean, really, like honestly, nothing changed. I made sure the fueling
Yeah,
was right, but we put in that turbo or the new turbine. It was the same compressor wheel, and just immediately picked it up.
yeah.
Um,
Well, I mean, the computer like did its job. Like it saw that the AFR was holding steady, and it was like, it can manage injector duty cycle, and just kept injecting more fuel because everything was staying fine, and power output went up.
that's another cool one that we've looked at with my car quite a bit, and you've shown me this too with diesels and stuff. Is like watching VE really carefully can be
Hmm.
a huge benefit because you can basically see if the engine is varying from its like naturally aspirated state with VE. So like you can just see if VE, like you said, if it falls off really early, or if it's holding out to the you're holding the NAVE all the way to redline with like my bigger turbine, or if it's cutting shorter than it should, then you can see that the motor is not happy there, um,
Yeah.
and that manifests in like AFR. So like on my car, you'll just watch like on the small older turbo I had, it would just tank. So like AFRs would just go, you'd be like in the mid 11s and go to like down to like 10, and it's just if it's not if I don't have fuel correction on and it's just using the same fuel table, you'll just see it like start to go rich. Is what you explained over when we were dynoing it. So
That's when I was asking. I was like, is it running out of fuel? You're like, no. Is it doing this? You're like, no. Is it doing that? You're like, no. And I was like, it's just the computer is doing exactly what it's supposed to do. The charger's just too small and it's going in the choke flow, and the choke flow is causing your VE percentage to drop, and the computer is following the VE percentage based off the O2 sensor reading, and it's reducing fuel quantity.
it's
And it
just
causes, yeah, it causes your layover points as far as peak torque, peak horsepower to be like sooner than they should be. Like the bare minimum is it should just take the NA numbers and just stack them, you know.
that's a really cool one where yeah, like Richard Holdner does a ton of those videos where he's like
Hmm.
he'll take an engine, whatever it is, and just put a fairly large turbo on it, so there's not as much of a restriction to show up on the graph, but you can just see like peak torque, peak horsepower just raise up like
Yeah.
exactly the same shape, and that's what it should do in a perfect scenario if you have like low restrictions, low uh, trade offs with a turbo system. So
Yeah. It's always like a really like cheap and easy tell. If you turbocharge your car, you go dyno it, and your peak torque and horsepower is lower than like the RPM wise. I don't care what the numbers output are. If where it lays over is at a lower RPM than the NA number, then the turbine's either the turbine or the compressor is too small. And usually it's the turbine side. It's too small.
that's one thing that you've explained with my setup originally I would have never thought the small 54 millimeter HE341 compressor could do like 560, but you're like, no, it's the compressor is totally happy doing that. Like it can do it. It's at that point I think it was on the edge of it, but it can do it just fine. And I had no idea it was all just turbine. Like that's one thing I think that's another kind of downfall sometimes of the like marketing of turbochargers in the industry is like it's all based on compressor. They're like, oh yeah, this will do like this compressor will do 500 horsepower, 700 horsepower, but then you look at the turbine and you're like, oh, it's like a 60 or 62 millimeter turbine. You're like, it'll do it on the right motor, on the right like
Yeah,
scenario, and one person will succeed with that, but like it's not really telling the whole story. And that's
definitely.
something that's crazy is like you need way less compressor than you think, but compressors are what's shoved down the throat of the like from media a lot.
Yeah, well,
It is needed,
generally,
but
yeah,
yeah.
generally like the compressor will scale upwards with the power output it's supposed to, but not always, and it's not how a lot of things are sold to like the public. And you can pretty much always have more turbine than you need, and you'll be fine. The worst thing that happen with more turbine than you need is you have turbo lag, but having too much compressor will cause turbo lag and a reduction in your peak horsepower, peak torque RPM. So like over compressoring versus the turbine size will push everything to the left on your dyno graph versus having too much turbine will just cause you to, in like best case scenario, it'll lay over peak torque and peak horsepower where compressor work input scales really hard. That's usually always after wherever the motor's going to lay over. Um, because you'll see it in like drive will just go through the roof. And then shortly after compressor burst happens, but it's harder to get there than it sounds. Versus having too much compressor and not enough turbine, it just takes everything and just pushes it to the left on your dyno graph. Like,
Totally. Yeah, I totally remember seeing that too. On my setup, when I still had the 54 millimeter compressor and then went to the 10 blade 67 turbine, it hardly moved boost threshold. It was crazy. Like I would have thought, oh, that's such a bigger compressor or a bigger turbine. It's going to hurt me like what you just explained where you can over turbine and it won't really hurt you as much. I think like boost onset where it started to make boost on the stock 60 millimeter turbine was like 2300 RPMs, and then as soon as I went to the 10 blade 67 mil, it went up to like it was like hardly different. It was like 2700 RPMs or something like that. It was like
yeah,
400 or 500 RPM difference on that engine. I could hardly tell on the street because most of the time you're above that when you're like getting into it anyway. So it's like it was great. Like I remember messaging you and being like, dude, I hardly feel a difference, but it's
yeah.
like way more up top. Like it pulls so much harder, but you don't get the trade off of like going too much right away on the compressor.
I mean, the big thing too, though, is just keeping torque in check. A lot of people get really stuck on spool up or factory torque. And the one thing turbochargers will make is much power until your motor is split in half. Like tried and true, guaranteed, we can do it no problem. So I kind of tell people is keep torque in check. Whatever your motor is rated for torque wise in the aftermarket, I'm like kind of stick to that. So like in the diesel world, a lot of these engines we stick to around like 1600 foot-pounds, 2000 foot-pounds, and then like for your car, we did the same thing. We stuck to around I want to say 600 or 700 foot-pounds.
Yeah, it was like
Like let's not
600.
exceed this. Yeah, like let's not exceed this number, and everything will stay together. And then we'll just RPM the thing to make the power goal. And that turns into a different problem where we have to start looking at cam and cylinder head, and we could do that in a different video. But I think a lot of people that get stuck on spool up haven't had to service head gaskets, connecting rods, blocks, pistons before.
Yeah.
Because Turbochargers will make more torque than your engine can handle, no problem.
Yeah,
The real question is how much torque can the engine reliably handle because you don't want to work on it all the time. And then let's hit that goal as close as we can so it makes the torque you want, but you also don't have to work on it once a month. Like, how about that? Yeah, sounds kind of nice.
absolutely. That's exactly. I remember. I specifically remember messages from you when I was on the dyno. You're like, yeah, you're like, just keep it like limited. If that's like the, like you said, the aftermarket known, like right around 600 foot-pounds. I've seen other people make them live on my engine up to that point, and then it's like, just don't exceed that. Keep the boost control at or a little bit below that limit, and then after
Mhm.
that we can increase boost incrementally up to peak power. But like that's the limit. But
Yeah,
as you've said, like, you can build a turbocharger to junk any motor. It doesn't matter
yeah,
what it is.
yeah. No,
Like, that's the
yeah, it's
cool
not.
thing is like the turbo's never going to be your limit. It's always going to be the hard parts
People are
on
like,
your
how much
engine.
power does this support? I'm like, as much as you want.
Yeah, yeah. Like, well, what? Let's look at your engine first because that's really the limitation. And
Yes.
I think that's any application. I know
Yeah.
a lot of people that are listening to this, they might be unfamiliar with diesels, as I have previously been, and I'm getting more familiar with them. But like, really, they're piston engines. They they have the similar limitations. Like, connecting
Yeah.
rod is always a connecting rod, whether you're making 1,600 foot-pounds or 600. At some point, that hard part has a stress limitation, and it won't deal with it anymore. So
Yep. It's still a diffusion flame combustion process. Whether it's compression ignition or spark ignition, the flame front speed is still subsonic.
and it has to be until it breaks something if it doesn't.
Yeah.
Like you're saying,
No,
yeah.
yeah, you put holes through pistons when it's not.
That's been a huge one that I've been trying to figure out with my car as well. Is recently I've been doing more testing on pump fuel, just 91 octane, and trying to keep it from knocking and detonating, and having that bigger turbine I think has helped that. But
Yeah.
it's a whole nother game, trying to keep something to not knock. But we can talk about that another time too. But it's been interesting. It's
Yeah.
always.
Well, yeah, especially like knock, 'cause I don't know too much about knock for SI engines, like DI compression ignition engines. There's been studies on it as well as my own theories on it, and then SI stuff as far as like spark ignition goes. I just have them as commuters, so I don't know too much about it other than it throws check engine lights when it happens too often.
Yeah. The the ECU gets mad. It tells you
Yep,
it's.
it's like torque is not because it's measuring crankshaft speed is how they do it, which is kind of neat. And it's like crankshaft speed is not what it's supposed to, and based off of crankshaft speed, it's these two cylinders. I'm like, that's some pretty cool coding. Like whoever coded this thing is smart.
There's a lot that goes into it that's
Yeah,
pretty intelligent stuff to keep them
yeah,
alive.
yeah. Like to figure out what cylinder is knocking based off of like crank speed, like the change in crank speed over time. It's like, oh, these like 1 in 4 is misfiring. Yeah, like yeah, it's pretty good.
It
I mean, it's not good for me because I own the thing, but
Yeah, but yeah, it is. It's honestly incredible where stuff is. Like, I think about that pretty often, and I'm like, man, we are in a time where it's like we have so much stuff at our hands. Like, I've got the Russ EFI. It's like $170 ECU, and it'll do everything. It's crazy. It's a community project, so it has a lot of backing from a lot of smart guys that put their time into it. That's where the value comes from, is like people putting their
hmm
time into it for free. But it's mind blowing. Yeah, I'm sure. I don't know if like the diesel world has a lot going on with that, where people have kind of willed something into existence that normally was extremely expensive, or people have come up with solutions like that. But it's pretty cool.
with hard parts, yeah. With the electronic parts, not yet. I wish it was like more common. I don't know why it's not more common because it's all the same stuff. The tone ring, like it's
I'm
a piston engine with a tone ring, like
Yeah.
it's pulse width modulated injectors and everything else. Like it's all pretty much the same stuff.
From what I've seen, and this is just looking into it uh, not very in depth, but the the difference I think is like hardware that can handle the like peak and holds that are necessary for those type of
Mm,
injectors. They just require quite a bit more control. The hardware has to be a little bit more specific and higher
I
quality. So that's probably been
can
the
see that.
limitation. But I think it's there will be a day soon where it's going away. I do watch some of these community projects, and I think the CDI stuff with diesels will be pretty awesome soon. I know that they've got other tuning stuff, but I'd love to
Yeah,
get like one of those Mercedes early 2000s CDI 6 cylinders and be able to tune it on a standalone
sure.
sometime. That'd be cool. But
Yeah, they're because that'll have a VP30 or whatever they're called. It's basically a miniature version of the 98.5 to O2 Dodge injection pump on those things.
the older 606s
Hmm.
and 605s and stuff.
Yeah,
You got like
same
that
stuff's on
mini
the
P pump.
TDIs, I'm pretty sure.
Yeah, those. But yeah, there's that's another thing. Just throwing out stuff here is like some of the differences I think with diesels and spark ignition engines. You'd think there's like a whole bunch of differences, and there are, but in a lot of ways, the way things perform and the way they show up on dynographs and the way they do things are very similar from what I've
Yeah,
seen. Like an engine, in a lot of ways, is an engine. Obviously, there's a lot of caveats there, but that's something that you've been able to help me become a little bit more like aware of is like a lot of the things that you learn on a diesel, like they transfer over, especially with turbocharging, very
yeah.
very easily to the spark ignition.
Well, regardless, it's a piston engine, and the only thing that makes shaft work is the BTUs of fuel, or the BTUs of energy inside the fuel. So because they're both piston engines, regardless of methanol, um, nitromethane, diesel, it's going to be the same process to take whatever amount of BTU that you have in your fuel storage, convert that into crank work. The when that BTUs are converted to crank work is going to be the same crank angle of degrees, regardless of the fuel type, because it's still a crankshaft piston engine.
And that's yeah,
Like,
that's the cool thing.
yeah,
I've been able to see a lot of the stuff that crosses over. So I've learned quite a bit from the diesel world, and didn't think it would ever make sense, but it does. It's really quite interesting, and especially the turbocharging stuff. I it all starts to make sense over
well,
time.
that's where like seeing like gas engines, like owners that have SI engines that put two small turbocharger on, that all comes from the turbo diesel side of things because most turbo diesels, peak torque and peak horsepower is located by the turbocharger. So I can dyno a stock truck, and then I could dyno a truck with a little larger turbocharger. Then I can dyno that same engine with a little bit larger turbocharger, and it keeps moving peak torque and peak horsepower to the right on the dynagraph. And eventually, you'll get to where the cylinder head and the cams, like the restriction, but you can take that info and then go look at a SI engine. And if you look at most SI engines, everybody puts on big enough turbocharger, they make more power, everything looks great. But like you'll get someone who puts on their stuff and all of a sudden peak torque moves left, and you're like, well, wait 1 moment. This is instantaneously what your issue is. Like they'll be like the injectors are too small, or there's not enough injector, or the header's not right, or the intake's not right. You'll be like instantaneously turbine side too small. Like you can have the compressor side too small, right? So the compressor side, if it's too small, it's gonna scale up compressor work really harshly, and it can do that right where your peaks are at. But that's rare. Usually, what happens is turbine side is too small, and it can't convert the exhaust energy to shaft work correctly. And in order to do what you're asking it to do, it'll just scale up drive pressure. And that drive pressure costs you power, and that power shifts everything left. Is what you're seeing. And so diesels are designed that way, where the cylinder head and the cam flows way more than the turbocharger does. So you can keep increasing the size and it'll keep moving it to the right, but that at the same time costs you torque to the left. And most diesel owners want torque at, 1500 RPM. So you can't trade one for the other. It doesn't exist. Compounds are a bit of a compromise and it works, but let's just say single turbocharger doesn't, you can't have this and have that. For SI engines, most owners are cool with having the NA torque under a certain RPM and then ramping that torque up once the boost comes up. And that's where making sure the turbocharger sized right for where that cam and head is on those guys' setups. This gets important. And it's basically it's the opposite for diesels is making sure the turbocharger is not so big that it kills all their torque down low because you'll hear about it if they can't tow the trailer and you won't hear about it as long as they kind of hit their power number on a dyno. They're cool.
That's yeah, definitely definitely one thing I remember asking you over the years about that. I'm like, why does a diesel have like 4-inch runners? Like I was like, because I'm like I'd be thinking about this.
Yeah.
I'm like, if you look at a diesel, like look at a 12 hour something, it has like the intake runner length of what like a 12,000 RPM engine would have, and I'm like, how does that make sense? And then you're like, hold on, look at the turbo, and then
Yeah.
there's a lot
And
of
like
things where like I'll ask you a question and you're like, look at what it's being fed by, and then I'm like, oh yeah, the turbo is the like overarching induction system
yeah.
boss. It's
Yep.
controlling.
Yeah, you're overthinking it and trying to fix a problem when the problem is like right in front of you. You're like
Yeah.
you're looking at it and you're like, nah, I
the
don't think you're the problem. I think this is the problem. And it's like, no, that's it right there. Just stop trying to spend time on everything else that is a waste of time when you still leave that thing exactly the same as it was.
Absolutely. And then as soon as I learned that, I would go look at like all the modern direct injected turbo stuff in like, for example, I'm most familiar with BMWs. It could be anything, whatever.
Hmm.
I actually, most people think I'm just BMW. I really don't. I love all. If it has a turbo and an engine, like a piston engine, I love it. Even rotaries, whatever. But like, I was like, okay, I'll take that knowledge and I'll go look at like new, like say it's a brand new BMW direct injected, uh, straight six turbo, and then I'm like, holy cow, this has like zero runner length as well. And then you're like, yeah, look at the turbo, and like the turbo's tiny. The turbo's designed to bring in peak torque at like 1600 and go all the way to like 58 and then taper off or something. And it's like that's like what the OEM is trying to do. Like they don't need intake runner to do that because the turbo is going to do it for them.
Yeah.
It was just
And
cool
then
to
and
see
then
like these worlds where I'm like, oh my gosh, the OEM is actually designing this the same way
mhm.
like Cummins had designed this engine as well. It's just cool to see
Yeah.
that.
And then they'll go in and they'll adjust trans tuning so that it's hard for the engine to even get up to that RPM where it's inefficient anyways. You can like the OEM can short shift the trans on purpose to keep it in the torque zone.
Oh yeah,
Like,
they have the full creative
yeah,
rights to do whatever they want
yeah,
to make, like you said. Yeah.
yeah.
So,
So they can hold the engine like that's like Greg Banish kind of talked about this where they like designed the pre-Raptor motor made more torque. I say more torque. It made the same torque as like the base level power stroke that it was going to compete against because they wanted a gas engine that can make the same torque as the diesel engine because the diesel emissions were hard to meet and SI emissions are easy to meet. So they designed this thing, but at the same time, Greg Banish was like, why don't we just like you could make the same as far as energy output to the tire. Like you can make a lot of torque, which is kind of hard on it is hard on parts, but it's less heat you have to bleed off. Or you can let the thing RPM and you can just use extra trans coolers and other coolers to take on that heat load. And usually in most OEM applications, they'll let it RPM to some degree because it's easy to dissipate heat off because the greater P1 and P2 is, the easier it is to get rid of it versus having a mechanical lever handle a torque load. You kind of like watch how a lot of OEM shift strategies and stuff are. They'd rather upshift, um, or downshift, however you want to put it, and let the converter make heat and then just get rid of that heat to handle whatever kind of energy input to the axle is needed versus trying to handle a torque load.
Uh,
Because torque breaks things,
Makes
and
sense.
heat doesn't break things usually. You just
Yeah,
have to figure out how to get rid of it, and that's easy in 2025.
yeah, I 100% can see that too, and agree. It's like heat. You're like, oh, but like nowadays, like you're saying, like you can just get on like the Summit catalog and order a cooler that's big enough that your trans will never come up to temp. Like if you want, you know what I mean? Like
Yeah.
you can, it's mitigate. You can mitigate like trans temperature, oil temperature, that kind of stuff these days. Especially if you have a truck. I someday I'll have a truck because I love the idea of just stacking heat exchangers in the bed and just putting fans and like all the heat's back there, and you
That
just
would
put
be a
as
good
much through
YouTube
as you want.
video of seeing how much can you tow with like 20 heat exchangers.
That would be cool. Just have yeah, like a hot tub of hydraulic fluid in your back, just
Uh-huh.
ready to go.
No, so we just did like a trans swap for a friend of my dad's, and he's like, "How much ATX on you get?" I'm like, like, like get like 26 quarts," and he's like, "The what?" I was like, "Yeah."
You're like, yep.
I'm like, like the whole system holds a lot. He ended up having like four left over. I was like, "Yeah." I'm like, it just keeps like diesels hold a lot of ATF.
I believe it. I mean, even my Forerunner that I was messaging you about when I was doing the all the shift kit stuff, I just like when I was looking at it, I'm like, it doesn't make sense to buy it in quarts anymore. I just bought it in a 5 gallon pail. It's like I'll just buy a
Hmm.
pail of fluid because it's way easier to manage.
Yeah,
It's yeah. So I believe it.
yeah. You do like a full cooler flush and everything. And it just keeps on going. You're like,
Sometimes I wish it was as easy as those like the tractor trailer stuff where you can just take the top off a transmission, just pour the thing in, or like a tractor where you
mm-hmm.
just dump the whole thing in. You're like, oh yeah, give me two more pails.
Yeah, there's no dipstick. You just like, yeah, it looks good.
Yeah, it's in there. There's a pool. Uh,
Yep.
Sometimes I feel like that's like the easy life is the bigger stuff, but sometimes not, I guess. But it's it's pretty cool. Well, I was thinking, I'm like, while we're here, we got um, we got time to where we could just go over a couple of like the most commonly asked questions that we
Yeah.
get, and I think first one on my end, like say someone is approaching me about my setup, or they're just approaching in general about going with a whole set, because I think that's where people always find me is they find me using whole sets and they're like, oh, whole set is a fairly easy to get thing, like they can find one locally, find it on marketplace or whatever, and they're like, I want to throw it on my car, like what do I need to do, or what model do I need to get it to work. So as far as using whole sets, what kind of advice do you have to give people that are using them on smaller engines based on like your experience with me and other guys, like
Um,
the Pine Valley guy running a Subaru, or like other guys
yeah.
running stuff? Like what
I can
is
get
your overall thing that you'd say to people
I can
just
get
starting out?
I think for 2 liter, 2 to 2.3 liter smaller engine, regardless of how high you want to rev it. Realistically, HE341 is fine. So that's Dodge diesels '03 to '04s. So it's a 2 year span. Usually you can get them for free or cheap because nobody wants them, and they're easy to identify because they don't have a command valve plug. So the command valve plug, if you have a compressor cover that doesn't have a big uh, threaded port on the front of it, I could probably bring one up.
I know, I wish I had. I guess we have
Yeah,
all the pictures in
that
the world of the internet here, but
that'll be an HE341.
that's actually how I found it. When I was first looking, I was looking at all the HE versions, and I'm like, that one has like the best looking cover that doesn't have a bunch of crap on it. I want that for
Hmm.
my car. That's kind of how I actually looked it up.
Yeah, no, they definitely look better.
And
The
it's a
problem
little bit
is
smaller. Touch.
yeah, the issue is that they're a 55 millimeter compressor. So that 55 mil compressor is only good for approximately like 500 wheel horsepower. So 500 wheel horsepower, plenty for what most people are after. But if you're after more than that, all right, there we go. So you should be able to see what I'm looking at, right?
Yeah, let me switch over to what you got here. Okay, cool. There we
Okay.
go.
So this is a 341. So 341 has just the MPT plug, and that's it. So if we look at these things, yeah, here we go. It's like a factory. This is O 03 to O 04. So no command valve plug. You have an MPT plug right to the wastegate actuator, and that's all you get. So these are great if you run these as they are, they're about they're designed for 230 horsepower at the flywheel on a Dodge diesel, and they'll do probably around, what you made 360, 340, 360 on the factory turbine.
Yeah, I was like, yeah, 380. Yeah,
That's
getting close
about
to
it.
2 to 1 back
Yeah,
pressure.
because it'll push your if your engine's not small enough. So smaller your motor, the better off you are with one of those things. But if your motor's too small, you're gonna have problems. Or too big, you'll have problems. So 351. I'll tell these things apart. 351 has command valve plug. So command valve plug is this guy right here. It's this electronic solenoid, and they make billet plugs for them. They have three O-rings. The O-rings on the cheap Chinese versions usually aren't the right size, so have an O-ring kit from Napa, O'Reilly's, Auto Parts, phone, switch it out. It'll plug it off, or you can take a cutoff wheel. You can cut this off, weld it closed, and then drill it for 8-inch MBT and feed your wastegate or feed your boost control solenoid.
I think the cover that you gave me right now has been shaved like that. It's really, yeah,
Huh?
smoothed off.
Yeah.
So it
Yep.
looks good. Looks really good.
Yeah. Yeah. You can cut these off. It's not super hard, and welding them's easy. But easy to tell 351 and 341 apart is a 351 is it has this big port for the command valve. 341 does not. So a 351 will have a 60 millimeter compressor. A 341 will have a 55 millimeter compressor. This guy will do right around 70 pounds a minute. So on a 351 with a factory turbine, you'll probably max out around 400 wheel, and then with the turbine modification, so same size turbine housing, but 76, 67 turbine, you'll max this compressor out right between 600 to 700 wheel horsepower, depending on the displacement in the motor.
It's pretty incredible, awesome, honestly.
Yeah.
And that's, yeah, like I think the yeah, and a lot of people will ask. I don't know. I feel like the people that want to run them find me, and they find the resources and stuff. There's tons of other good stuff out there, and like I mean, you even work with a lot of the PSR guys and stuff, and like they make a good
Hmm.
unit, right? And so
Yeah.
like
Yeah.
there's yeah
Yeah, if you don't want to use if you don't want to use a Dodge specific turbocharger, even the other stuff that they carry is fine for like a lot of, I would say like low to mid boost applications. Their stuff's great. The only reason, and I don't think that anybody's stuff sucks. It's more so you should have anyone's stuff checked out by a builder you trust
yeah
if you're going to run high boost, and that's because of the torque spec on the compressor, the clamp load, compressor wheel to turbine wheel, as well as your bearing and all your oil clearances. If you're going to start running, yeah, if you're going to
so
start
like
running, 40 plus pounds of boost and a lot of RPM, there's a lot of dynamic motions going on with that shaft, and it's not a bad idea to just have someone check it. It's cheap. It's usually $200 to $400 to have someone make sure it's good. And if they're honest, they'll tell you whether you're gonna explode it or not.
yeah
Like I've done that plenty of times where someone like, I want to turn it 5,000. I'm like, it's gonna explode.
yeah
Not a great idea to turn it 5,000 RPMs with 6 liters and 60 pounds of boost. It's just gonna come apart.
yeah. It's not gonna be a good day.
Yeah. Yeah, it's not great. You need three of these things instead of one of them.
And so
Hard to live.
that's something people can also reach out to you about. They're like, "Hey, I have a turbo.
Yeah.
Can you give it a once over?" Um, and stuff like that. And you have all the equipment to balance them, make sure they're right, and
Yep.
like you've shown me stuff too where like out of the box you can have bearing clearance issues where, like you said, it may be okay, but it might not be okay if you're going to push it, right? Like it's relative to what you're going to do with it.
Yep, that's why like there's a lot of people that like hit and money's nice and we all could use more money, but at the same time I always kind of think about it as we could all use more money, but there's also like if I was in his situation, I'm looking also to not try and spend money. So people like hit me up and they're like, "What do you think about this?" I'm like, "Well, how much pressure are you running? How fast are we gonna turn it?" And if it's not really like an extreme case, like it's like 13 pounds of boost, 50 pounds of boost to 5,800 or 5,500, I'm like, it's you have like a 98% chance it'll be fine. Like you don't gotta pay me anything, put it on there, run it, and you have the option to still send it to me and or anybody. It could be work turbochargers, Midwest Turbo CRT, all these places. You could send it wherever you want. But I'm like a lot of times at these lower loads, lower speeds, I'm like you'll be perfectly fine. Nothing wrong with it. I don't need the money. There's somebody else that's gonna break something tomorrow. I'll fix that one instead. Like,
Yeah,
yeah,
absolutely.
like you're good. Enjoy your thing. Spend it on injectors or something.
Yeah, I think that's a another thing too is like a lot of the, a lot of the people trying to mess around with these, including myself, like I was, originally looking for something that was like OEM quality, but you could find it on the aftermarket fairly inexpensive. Because like obviously I look at this stuff like crazy because I just love it, but like you can find all sorts of like eBay or inexpensive, turbochargers.
Yeah.
But in my mind, when I was originally looking for something for my car, I'm like, I kind of want something that I can just throw on there, and even if it's secondhand and used and whatever, it's like to an OEM spec where if I just make sure it's cleaned up and doesn't have any damage, it'll just run. And so
Yeah.
that's where like for me the whole set like shined in my mind. I was like, I could probably put this on here and I'll never overload it. Like with what I was trying to do at the time, I'm like, I'll never hurt this thing.
But they're 500,000 mile turbochargers like any day of the week.
It's yeah, I
Like within their OEM motor speed and all that fun stuff, like they'll go 300 to 500,000 miles, no problem.
there's a guy just hauling hay for 500,000 miles, not pushing it past stock, and just having really good luck because doing maintenance, right?
Yeah, yeah. No, I get it's like once a week I'll get someone that like my turbocharger's tired, it has 130,000 on it. I'm like, yeah, no. I'm like, there's probably your CCV is probably having issues, or engine oil levels too high, or been on incline for too long. There's something else kind of maybe going on. Air
Something showing
filter's been
up.
dirty for too long. Yeah, that's making it look like the turbo has problems. Because I'll get it in, take it apart, measure it, and check it, and like as far as your hard parts go, they'll be perfect, the most year. So the HX35 40 351 341, like it's a 15.88 millimeter through bore, 15.08 at 60 degrees Fahrenheit, bearing OD 11, it's like 11.006 millimeter bearing ID. Like they'll all be the same, like they're fine.
I love
Like,
that.
and I mean,
Oh,
yeah, it's like, nope, I do too many of them. Like, I know off the top of my head.
I love though that the fact that on this stuff where it's more high precision, it's you have to set a temperature for the tolerance. That's something
Yeah,
that I think gets misunderstood.
no, it's
Sometimes
been,
you're like, when it gets fine enough, you have to check the temperature at the same time you're measuring. So
yeah, no, it's been warmer. No, so it's been around like 70, 80 degrees lately. And it's gone from like an 11.006 millimeter ID to 11.01. And that's just because it's warmed up. Or if you hold a bearing for too long,
oh yeah,
yeah, it'll change size.
that's
Like,
really cool. I think that's
but
pretty fun to see.
yeah, like if you heat them with a torch to 180 degrees from 60 degrees, they'll grow 0.03.
I I I love that that's a physical thing in the world because I think it's awesome. Recently, I was changing a carrier on my differential, and the ring at like room temperature it doesn't go on. I hit it with a torch for like a couple minutes where it's like kind of hot to touch, falls right on. I was like, dude, so cool
Yeah,
that like
yeah.
thermodynamics work like that and properties of materials and stuff. So
I don't even like waste. I used to kind of like fight getting some compressor wheels off of turbine shafts that were tight, and anymore I have a map gas torch that just sits right underneath the vise.
You just like
Just grab it,
hit it.
heat them up a couple, 50 degrees, and pop right off.
I'm sure, yeah, especially with aluminum, they
Yeah,
do. But and yeah, like I feel like we could do a whole episode on whole set stuff because like over the years I've asked you about pretty much every like model range of whole sets, and there's a lot of cool things about each of them, and there's a lot of
yeah,
things for performance that are kind of pitfalls and stuff too. But I think probably for most people that are looking at this, the reason I used them is because yeah, they're like you can find one that's like slightly used, someone upgraded. Like the one I got was just a dude that just upgraded to something else, and it was like 130,000 mile off his truck. Originally, I got it for a couple $100, and it was in great condition. I just cleaned it up, and that's it. And so, those are really the reasons I was looking at it. OEM quality, inexpensive, lots of good repair parts. There's people like Bradley that know them in and out, and you could like send it out for a freshen up, or if you like, I had a friend that I think he dropped his turbine, and you were able to find him a good used one and put it together for
yeah.
him and stuff. Like there's a lot of like stuff that's just available that if you have the right person like Bradley know how to do it, they can just put it together for you real quick, and it's relatively inexpensive to have it worked on and stuff like that. So
I do think one thing to kind of take into consideration a little bit. I don't know how big of a deal it is because I don't own a SI boosted engine.
yeah,
Is that most diesel turbochargers are geared at like 2.0 higher pressure ratios. And we've noticed this when we're testing pressure ratios on your car, like drive versus boost. Your drive to boost is worse at a low boost target. And then as we raise the boost target, the drive to boost gets better.
absolutely.
And that's just the compressor geometry as well as the turbine geometry is geared at being efficient at on both ends at higher displacement ratios, pressure ratios.
I
But I would say that just something like if you only want to run like 5 pounds of boost, I don't. I think it would be like perfectly fine. But if you're looking for like the most efficient thing at 5 pounds of boost, I would probably choose more along the lines of a Garrett or Ford for that target versus a whole set unit.
Absolutely. I remember, yeah, looking at some of that stuff with my card too. Like, it wasn't happy until it was at a certain pressure ratio, and it's almost always past 2 to 1. Like, it's hardly even worth looking at sometimes on the data with my car unless it's at 2 to 1 or above, because that's when you really start to see everything shine. So I remember kind of all that stuff that we've looked at with the diesel, yeah, the diesel compressor geometries on at least on this turbo.
Mhm.
But yeah, that's another thing I would love. If we get this sorted out, this is our first shot at doing a kind of
Yeah.
a podcast style video like this. It'd be fun to do one where we literally just you hold up and we look at pictures of all the different geometries of compressors, because that's a fun conversation. I always enjoy those when we are going through all the different reasons for things, because the problem with me is like I have like an insatiable desire to learn about stuff. So like the problem is I'll pull up a page on like turbos, and I'm looking at turbos and I'm like, why does that compressor have 11 blades and this one has 9, and why does this one have 2 splitters for every blade and it has 5 blades? And like, and then I message Bradley, and it becomes a really cool conversation, and there's a lot of things to learn. But I think it's for another video, but I think there's a lot of cool
Yeah.
stuff like that.
Nah, yeah, it's for sure like another because that's the volume versus velocity thing. Like that
There's
gets complicated.
And I think one thing that we could take away from that, just in a very simple way, is the easiest way to explain all of that. Like every single thing, like in the aftermarket or even OEM, is that something had a design for a reason and it had a target for a design. And as soon as you can just like accept that that's a thing, like you'll be like, oh yeah, this turbo was meant for a truck that was gonna like, steady state. Like say it's for like a semi truck or something. You're like, they're planning on this thing steady stating from California to Florida and for the
Yeah.
most part, holding a load of like 50,000 pounds, just going up hills and stuff. So like, there's like different reasons why an OEM would design
Oh yeah.
a turbo that way, and that's the easiest way for me to wrap my head around it. It's like, why is like, well, one will do something better than another, and it would be for a specific application that's like targeted. And so, yeah,
Or one will break if you design it to operate there, which I know too well about. It's very, very expensive to learn that lesson of far as like gas harmonics through turbine shapes.
that's
There is a rhyme and a reason as to why there's so many blades, why the blades are shaped how they are, as well as the intent of the turbine housing and the displacement of the engine as to why the system is what it is. So you have to be very careful when you just go either change blade shape or delete blades or put housings on things that they weren't originally intended to design to run on, because you'll create volume and gas velocity things that cause harmonics that break things. And I've done that. It's expensive.
you have, yeah, you have a lot of cool testing uh, in that area. I've seen a lot of your the videos that you've sent about certain experiences with like, well, this didn't work or this worked great, but the
Yeah.
that's where like Bradley shines. I think is he has a huge background and repertoire of like what works on applications, and especially in his diesel world. Like that's where people that are unfamiliar with him, like he is able to custom build a turbocharger for an application because of all of the testing and all of the data and the things that he's gathered over the years. And so that's also kind of why like the SI stuff that I've messed with and we've been able to help other people have success with just here and there with SI stuff is like, I've helped in, give a little bit of data here, someone else gives a little data, and it all adds up into like, that's why you would choose someone that has a really big background with this stuff. Like, I
Yeah.
think sometimes people are like, oh, it's easy to just say like, oh, I can just Google this and figure it out. And there is a lot of good resources there, but sometimes getting an expert in the field, that's where you may end up, needing to find someone to do that if you're doing a really high level or like if you're going into what's it called, uncharted territories. You
Yeah.
may need to consult an expert that can tell you where pitfalls are going to happen, because like Bradley said, like you may, if you're trying to experiment with something on stuff that costs a lot of money, you should probably consult experts, because going with the wrong choice may cost you more money than you think. It might not be as
Yeah.
easy as swapping a turbo, because the turbo will swap itself when it blows up or whatever. Not that that happens in every case for fun cars, but like competition, that's where like you're getting a lot of guys really happy, I'm sure.
Yeah. My thing is always like too, if you can not confuse, but if you can ask the expert a question that's within their wheelhouse and they don't quite have the answer for you, if the expert is excited to look into it with you, you're in good shape. And if you're kind of like dismissed as in it won't work, then you should find another expert, right?
Yeah,
Like
yeah, I
it's
guess
kind of how I look at it
that's a good point.
is
Yeah, it's a really
like because there are times when you'll ask dumb questions, and if they can tell you that it's like if they can kind of point you in the direction you're looking for without telling you that it's like a dumb question you asked, you're in like good shape, right? Like
yeah, yeah,
they're teaching you without telling you they're teaching you, but
yeah.
they're not being
There's
rude about it. And the same with if you kind of ask something where it's like if you can ask like a genuine question, because that's hard nowadays. Like because you might like I always kind of think it this way is like we think that we come up with new stuff, but man, they've done most of this stuff in World War I and World War II. Like it's kind of crazy how much they've figured out. We just kind of we've definitely forgotten more than you learn. So if you can actually like stump one and they're kind of like they're hyped up about it, you're in like great shape because they'll stick with you. They'll help you out, figure it out. And then if they already have the answer and they kind of just point you in the direction, you should kind of be, nice to them and listen to them just like a little bit. You don't gotta listen to 100%. If they tell you not to do it, then maybe you should try it if you got the money to try it.
Yeah,
And if you like, sometimes it's worth it to kind of figure it out on your own.
that is
I mean,
definitely
that's like, yeah, like
is,
the whole reason I'm kind of around with the turbine housing stuff is just like staring at turbine housings, and I'm like, that turbine housing can be on that turbocharger if we cut it and weld it and machine it, and that took 2 years to figure out how to do it, but made it happen.
but that's where the as I've learned, that's where the magic is in
Yeah,
those that knowledge and that testing and understanding is kind of invaluable for the turbo world.
yeah,
Because it's not every day um, not every day that people can do that really. And yeah, it's pretty awesome stuff. There's so many things I was just thinking about. Like, man, there's stuff like you just mentioned where we were talking about the great horsepower race. Like pretty much everything I read in that book. This is basically a book that talks about all the internal combustion technologies that they were putting into World War II aircraft,
yeah,
because it was literally like life or death, basically having the faster plane. And
yeah.
they've, like you said, they've tried everything. Like I'll be reading and I'll send Bradley like a snippet, a picture of like something, and I'm like, dude, this technology they tried back way back when, and like look at that. It's like, oh, they do that in drag racing these days or something. It's just always interesting to see like the people back then were so clever and so intelligent and had so much. They had ideas that at that time were huge. Nowadays it seems simple, but they've all done it basically, is what we've seen, which is
Yeah,
really
I was
cool.
like, I mean, once you kind of find out that Germany, once they got those planes up to a high enough elevation, would hit a switch, and it would switch over to a DI fuel that would compression ignite and then make more power. And it was essentially like close to like a nitromethane with TNT like
Isn't
type
that
of
so
fuel
cool?
mixture
That's
to make it function at elevation. And then someone had to sit in that seat. You're like, you know what? That's pretty wild. Whatever I come up with probably ain't gonna be as cool as that.
yeah, that's the same feeling I get every time I read that book. There's so much cool stuff, and then like you said, being the test pilot for some of that stuff, I was like, I don't know, man.
Like
I don't know about that,
inject,
but it's pretty incredible.
just injecting like a liquid touch explosive into your engine,
Yeah,
20,000 feet.
it's pretty wild.
Like, yeah.
They were able to come back with any data at all is kind of amazing.
And there,
But
that's what's always kind of crazy about it now. But that's also what allows, I think, a lot of people to learn. Like, it's it is if you want to look for it and you actually, if you don't want to ask like a dumb question on Facebook and hope someone answers it, just Google it, because there a lot of times there's a free paper out there, if not more than one, that has the exact answer you're looking for, and all you have to do is spend a little bit of time reading,
yeah,
and it'll
absolutely.
be in there. Like it's not always directly in there. Like it's not the title of whatever, NACA paper you're looking for,
But it will be
but it
there.
probably exists. Yeah.
Like there's always yeah, there's that's one thing that's a benefit is like it's uh it's hard to feel like you have a novel original idea in these times with this stuff, but it's also really cool that people have already done it. So if you're interested in it, you can pretty much easily find it. Like previously,
Yeah.
there's been a lot of times where I'm like, oh, why don't we use like why do we use radial inflow turbines on a car and not axial turbines? And then like you Google that, it's not going to be on the first one, but if you go to the SAE papers where people have like tested this and they're like they built some study and they did it and like had
Yeah.
a university funded or something like that, there's fundamental research that has been done about pretty much everything you could imagine. And like Bradley said, you have to read on it, but like if you're interested, the reading's really good most of the time. Like pretty much any SAE paper I've read that's like about something interesting, for me in those cases, like I want to read it. Like it's, you'll find it if it's there. And yeah, SAE papers or like scholarly articles published by universities or people that have done this research and made it public is like a really good place to start. That's a good one. I sometimes people ask me like, oh, where do you find this stuff? It's like, well, you got to kind of dig deep or go into like textbook level stuff. So sometimes it's not as like quick 5 minute video on YouTube kind of thing.
I always like if I find like a research paper and it's like 8 pages long, usually I just like back out of it almost instant. Like I'll quick scan it and look. Then if I find like a research paper that's like 60 to 200 plus pages, I'm like, I know I'm in the right spot.
Yeah,
Like
you're gonna be like, this is good.
there's probably something in here that I can like learn from.
Especially if
Because they're not
matches.
a lot of times you're not like looking to learn the whole paper, right? You're like looking, and you want to make sure you don't have like we all have confirmation bias where
You're
you
looking
are
for it.
looking for your answer to be proven right that you already preconceived. That's inherent, I think, in human nature because I do it. Like
It's
I try
hard.
not to,
I
but
do it
yeah, we
too.
all do it. But at the same time, that look because you're looking for that answer, you come across other stuff. So it's fine to have it. Just make sure when you come across it, like don't let it instantaneously make you like try and find counter arguments or at least arguments that make you question it. It's always good.
Absolutely. And it I don't know. It seems also like I probably said it a bunch of times even already, but like pretty much any time I'm looking for something, it's just what I'm trying to make it work on is the wrong application. So I'm like,
Yeah.
oh, this will 100% this will 100% work, but not on my car. Like
Yeah.
if you have, yeah, it's like things like that. And so it's not always or there's some fundamental physics, there's like a physical property of whatever I'm looking at that's like, no, this is the restriction, this is why it doesn't work. And like, yeah, SAE papers are really good at like pointing that out.
Yeah. Oh, we also too like always look for like what's the least expensive thing that
That's
provides the biggest reward, and you'll get to the point where like I'm like with your car, I'm like yeah, like the cam and the cylinder head. I mean, you know it too already, but I'm like that's probably the limit, probably a better answer is your head gasket and your connecting rods.
mm-hmm. Yep.
Because
It's
we could certainly make more power, but if we can't turn it faster, then we got to make more torque. If we make torque, then it's going to be a head gasket connecting rod kind of deal.
absolutely.
Like what's something's going to go first?
I am super stoked and grateful that I haven't had to do really much in those departments, but it's, I think, not trying to toot my horn, but when you take a really calculated, careful approach, which I know is difficult to do for a lot of people because they just want to go. I know how this is. I have friends that they build a turbo car and they are like immediately like raging it until it blows, and like that's just they love that. And but
Yeah,
I'm a little more careful and calculated. Not saying that that isn't a good way to go, but like the reason I probably have had more success than some other people with keeping an engine together. This isn't like making a gazillion horsepower, but like the reason I have a lot of that is because I watch things extremely carefully on the tuning side, and like yeah, we're monitoring torque, we're comparing it against other people that have similar
yeah,
setups. Like I'm consulting with people all over, including like Bradley. Like I'll throw stuff by him all the time, and that's why like I've been able to kind of get as far as I can. But I think we are nearing the limit, and that's something probably another video we can talk about too. But like I do plan on going back to the dyno and making over or at 600 wheel with the compressor that we have on there now. I
yeah.
haven't dynoed it on the latest version of the turbo Bradley sent me, but I'm almost certain it'll do 600 no problem based on the plan that we have and keeping the torque down and then just letting
Yeah, I
it
think if we
letting it make
got if
600.
we only got to pick up 40, I think we got that no problem.
What's that? Sorry.
So if we only have to pick up 40, I think we have that no problem
Yeah,
with the
I
new
think that's
setup.
right. It's just it's one of those where it's like it's an unknown kind of where I'm at is the edge of the unknown from what I've seen anyone else do because
Mhm.
the and part of like what I've tried to do with my channel is a little bit of what Matt Happel does with like sloppy mechanics where people traditionally with the engines that I've run, it's not so much nowadays because there's a lot of people doing it, but like originally like the first thing someone does when they're like, oh, I need to make 500 horsepower on this old BMW engine, let's put H-beam rods in it. And I'm like, what if we didn't open the engine and the rods were like really beefy because they were designed in like the 70s? You know what I mean?
Yeah.
Like the basically has tank slugs for pistons. I'm like, these can probably take some heat. Let's just like take a calculated approach and like maybe work our way up. So I just wanted to show that things could be done on the cheap if you do them right, but it's very difficult because I don't like to hurt people's feelings, but a lot of people aren't willing to do it right. Even if it's inexpensive, there's a difference between like spending a ton and doing it right and doing it right on a budget. Like I, I don't, I don't ever like
No,
want to make
well,
people feel bad, but there is a way to do things the correct way, but
yeah.
like cheap.
Well, even still, you can. I always kind of break that down even further mentally, as far like I break it down to like flame speed and torque output. Like what's the bore, piston design, and flame propagation rate. Like if we get, as long as we mitigate knock and redetonation, like what can the factory rod head gasket, um, head bolt orientation and design, like what was that engineered to handle? And as long as you handle so your torque output is your flame propagation rate versus the rate of piston travel down the bore, sets up what the BMAP is, your base metric. Mess this up. It's basically your average cylinder pressure, which you can convert that over to torque. Can it handle it? And if it can handle it, what length of time can it handle it for? Which sets up your RPM range. Like those are all the things you can like look into. So if it like if you look at like a 350 Chevy, those rods can't really handle a lot of torque, but you can RPM the thing reasonable amount, add boost, make power. And then same with like your engine, we kind of have a pretty good idea based on history from other people trying that 600 to 700 foot-pounds approximate limit. Yeah, same with like I said, the diesel stuff, like the 5.9, it'll make 2,000 foot-pounds. You can make it wherever you want. Just the lower RPM you make it, the more often you might be servicing the head gasket.
Yeah,
Yeah.
absolutely, absolutely, and
Because
like
it's pressure versus dwell time on that stud set per cylinder that's being stretched is what you're looking at. You're compromising it. Best case scenario, take out the head gasket.
so it's like the best way I've seen it explained is like yeah, the lower engine, say the torque is constant, lower engine speed is you're putting stress on that connecting rod for a longer period of time at a lower RPM because the dwell
Uh-huh.
time is longer, right?
Yeah, if you look at the milliseconds of pressure induced upon that stud set, it gets longer the lower the engine RPM gets as torque goes up.
Same with the head gasket too. So,
Hmm.
but that's yeah, I'm honestly kind of blown away. I think a lot of the stuff that I mess with is just like over engineered old engines, like basically a
Yeah.
tractor engine in the if you compare it to modern technology, I'm running a tractor engine. Like Bradley one time you were telling me you're like, dude, we should just put a P pump on that thing. It would
Yeah.
basically be a diesel.
Yeah,
I'm
you
like,
got
hell
two
yeah, let's
valves,
do
you're ready
it.
to rock
Let's
and
put a
roll.
P pump on it. Let's just drill it
Like
out.
you got like a dish in the piston already? Or like we're good to go.
Yeah, I thought that was the best thing ever. I'm like, you know what? If I had the time and care enough, I would totally 100% try to figure out how to get an injection pump on that because it'd be funny. I think it'd
You'd
be
probably
hilarious.
run.
It would be, yeah.
Like just deck the head so your compression ratio is like 17 to 1, it'll fire.
That's so, it's, yeah. Honestly, mind blown. Then you just keep it in that limit. But it is, yeah, it's tricky because really, I think the limit we found on my cylinder head is just the it has a Hemi head. It technically should flow pretty decent, but the
Well,
or the port angle and valve angle are less than ideal for that, right?
it's a low RPM design,
Yeah,
and you
it's
can't raise the RPM of the design because of how flat your runner is to the your
I wish I
valve, your port angle to the head angle is, so if this is the floor, it's too flat. So if you had a runner like this, then you could port it backwards. You could port that back, but because you're already here, there's nothing to remove. You can only make the runner larger. So all it does is just move the RPM range of the engine higher and kill torque down low.
so you'll
Which is
lose.
and there's nothing wrong with that if that's what you're after, right?
Yeah,
But if we don't want to kill like the power at 3000, then that's why we decided not to touch the intake runner.
absolutely. Yeah, I remember showing you pictures and stuff of that, and it's like I hope I'm using this as correctly as I can, but it has a hypercritical short turn
Yeah.
radius
Yep.
because it's
Yeah.
meant for low engine speed. On
Yeah.
that,
If it's a four, if it, listening to Darren Morgan, if it was a four valve head, it'd be different. But with it being a two valve head, that short turn it's there. BMW put it there for a reason, and they put it there to make torque at low piston speeds. And they traded that off for not making torque at high piston speeds, which is fine because most of the people that are buying those cars aren't turning them 6 grand, right? Like, remember,
absolutely.
like it's grandma, grandpa, regular Joe Schmo driving it around. They want to tip into the throttle when it's at 2000 on the tack, and it goes.
Yeah, it pulls out of a stoplight pretty easy.
Yeah, yeah.
And that's what that motor is
Or
known for. It's known for being like a torquey grunt motor that's just kind of fun to rip around in low RPMs. Yeah.
Yeah, and you have like most motors, you have a 1500 RPM window to make power from wherever peak's going to be. From peak down low is going to be peak torque to peak horsepower is 1500 to 2000. So that's your range. So if you want an engine to pull if you want it to like pull hard to 58, then you're going to put peak torque at 28. So if peak torque's at 28 and peak horsepower is at 58, and your cylinder head and cam design is designed around that. So
Absolutely.
if you want to turn it higher to make more horsepower, you're gonna have to like without going to a new cylinder head, you're gonna have to kill off all the torque down low. And I don't think that's a compromise most people want to make.
Yeah, I think
Like it sounds great on the forums, like right when your signature underneath your forum post has yada yada 700 horsepower, but I always kind of tell people, I'm like, you have to drive that every day.
yeah.
Like just remember, you can't pass somebody driving to work or from work to home unless that thing's wrapped up to 7 grand.
Yeah. Yeah,
Like,
that's
so
true.
it's and beforehand you could pass somebody at 4,500.
Yeah. And it's a
So
noticeable
was
difference.
that power number worth it or no?
Absolutely. And yeah, with my car, honestly, it would in for what I use that car for and like what I think it would be great at was like if it had an auto that just could hang right at like
Yeah,
peak torque, I would love like if like the new 8 HPs and stuff where you can basically electronically control every shift and it's got 8 gears. Like that car would probably be a missile with 645 foot-pounds and like 560 horse on a transmission that actually shifted. Because right
yeah,
now I have like it's a transmission designed in the 60s, and so like I have like 700 millisecond shifts. Like I cannot shift
yeah.
this thing fast, and I don't want to shatter the transmission, so I don't.
No,
But like if it had an auto, it would probably be like really quite quick, but it's not set up for that. But I wouldn't give up high RPMs on this particular engine for like how fun it is just cruising it around. Because like I can be like doing 2,500 RPM on the highway in fifth and just roll into it, and it will just immediately make torque with that turbo, and you can pass anything quickly. So
yeah. That's like Darren talked about, like on the LS heads. If you lay that you're not if you have the certain LS heads and you lay that short side over, like you'll kill close to 100, 200 foot-pounds at 3,000.
Oh,
I
absolutely.
mean, and that's your tip in RPM when you could try and pass somebody, you know?
Yeah, it's like right where you're
Like,
trying to make it.
yeah,
Uh, that's absolutely true.
it's like just like laying the throttle and like nothing happens. Like, it
Uh,
kind of sucks.
dude. Well, I'm looking at the time. I don't know how good you
Yeah,
are on it, but we're probably want to wrap it up, and then we'll do another episode. I mean, we got tons of different things to talk on. Today was more of just kind of like a get started, kind of see how this form works. But
yeah,
hopefully, we'll have some opportunity to get questions in and stuff like that later on, and maybe do a live version. We just wanted to see how this worked, but I don't want to.
yep.
I want to mind your time, and yeah,
Yours
we'll
as
get together
well.
again soon.
Yeah. Hopefully, if this goes online, hopefully this is creates some questions because that's what really drives conversation. So,
Absolutely. And like we want, yeah, I want people to know, yeah, yeah, leave some comments if you have anything, if you made it through this long and you're interested, let
yep.
us know if it was a good format. And yeah, hopefully we'll get some more opportunity to where we can answer questions and get more stuff that people want to know out there for them. So
Yep. Yes. Remember, a piston engine is a piston engine, whether it's
absolutely. Yep.
spark
Doesn't matter
ignition,
what it
compression
is.
ignition. Like they're both subsonic flame fronts, and it's a good thing that they are. So
Absolutely.
diesels don't detonate, and spark ignition engines shouldn't detonate. No.
Absolutely.
Keep that in
Well,
mind as far as stuff to think about.
cool. Well, thanks again, Bradley. Thanks for your time. This was fun.
Yep.
We'll try to make it happen again here shortly.
Yeah. Hopefully we get some good topics coming up.
Absolutely. All
Well,
right.
see it.